The area of parallelograms, we're also going to do area of triangles and area of trapezoids, and we're also going to touch upon squares and rhombuses. The area, as we discussed, is the number of flat 2D surfaces hold units an object takes up. And we tried using this shape, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and that's the middle. Now, we did discuss how the left side, if you use the formula for triangle, gives you 10 units. The right side gives you 10 units, but we tried counting it, and why we had to use the formula is 1, 2, 3, 4, 5. We get all these little green parts, which is like little extra pieces that don't make an exact whole. So one of the things we all recommended that we sit through is the idea that if you can count it, like on this coordinate plane, if you could count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, you can count them, that's great, or you can use the formula. The formula is base times height, 6 times 3, 6 times. So how does that actually apply to the other shapes? Well, we have squares. Because all the sides are the same, we just say s squared instead of base times height. And triangles. Triangles, there are two different types of triangles, but they use the same formula. The first type of triangle is 1/2 base times height, but the height is inside, it's the altitude in the middle. And the other height is on the outside, which is right here on a right triangle. We did trapezoid, where the bases are the parallel sides, when you use 1/2 height times base 1 plus base 2. And then we did rhombus, which is a continuation of a subject we actually already touched upon earlier in chapter 8. And that was area of rhombus is 1/2 diagonal times diagonal, which is 1/2 8 times 6 for this particular shape. Now, to move on, I wanted to show you, this is the MCAS reference sheet. We have now clicked through, we could say we've successfully gone through square, rectangle, parallelogram, triangle, and trapezoid. We're going to do circles. But that's where we're at with the formulas on the reference sheet. But your homework last night, we did number 1 here. Now for number 1, I want you to notice the shape they gave you was this shape, where the base, Chloe, the base is what? What's the base? 30. But if you rotate it like they tell you to rotate it, because they put the height here, if you rotate it, you get a nice 30, 60, 90 triangle. But the base now becomes 20. So area equals base times height. The base is 20, but if you use the 30, 60, 90 triangle, you end up getting that the height is 15 square root of 3. Multiply it together, you get 519. Now, I am now going to demonstrate how this triangle down here with the base of 30, if you find the height, it will get a different base and height, the same area. But because some people say my videos could be dull, I'm going to add some dramatic music. So now we need to find this triangle. This triangle now is the one going down. If we find the 30, the side across from the 60 of this triangle, we will have the new height. And that is how we got 10 square root of 3. The base is now 30. 30 times 10 times square root of 3. Look at that. It is also 519. So, no matter how you rotate the shape of a parallelogram, it will always give you the same area because it's the same shape, just rotated. And that is area of a parallelogram.